I don't want to make up any more days of school. Okay, guys, so 7-3 is the last lesson I put in your notes, but remember I put part 1 because I couldn't remember exactly what all we covered in the first test, and we actually do go through one more lesson. So we'll have another lesson next week on Tuesday and Wednesday, and then we'll review Thursday, and then you're going to have a mid-chapter test on Friday. So that test, it's already on the calendar. It's going to cover 1 and 7, that's in this notes, 2 and 3, that's in this note packet, and then lesson 4, which I will give you on Tuesday. Okay, so be preparing for another test next Friday. That's only your third test of the 9 weeks. How many more do we have to go? 3, because we have to get to 6. And next week is week 5 of the 9 weeks. It has gone by so fast. So be prepared to have a test about every week and a half. Okay? Alright, so 7-3 is all about similar triangles. Now, we were able to tell whether triangles were similar in 7-2 if we had every piece of it, every angle and every side. So basically, this lesson is about shortcuts. Are there any shortcuts if we don't know all the angles and all the sides? Why, yes, thank you for asking. There are 3 shortcuts. Okay, so we're trying to determine whether triangles are similar based on the 3 shortcuts we're about to learn. The first shortcut is called AA similarity. That means that of this one set, which is 2 triangles, if 2 of the angles are the same, then these 2 triangles are similar. You don't even need the sides. Okay? So in this first triangle, we see that we have an angle of 90 and an angle of 30, and then 90 and 30. So are these 2 triangles similar? Yes. Now, if these 2 are the same, isn't the third angle the same? Based on the third angle theorem. So this one was best case scenario. Sometimes you'll get to ones like number 2, and you'll be missing the third angle. And you'll notice that these 2 angles aren't the same. But I would not just assume that they're not similar. I would plug it in your calculator, subtract from 180, and find what this missing angle is. So this missing angle is 15. And then this missing angle is 20. So I know 140 and 140 are the same, but there's not another set. So these are not similar, but I would make sure to check all 3 angles. Okay, I want you to try 3 and 4. But on number 4, make sure that you realize that these right here are parallel symbols. Okay, try 3 and 4. What did you say for number 3?
Yes.
What was this missing angle? 40, and then this one must have been 88. Okay. So, yes. And then I'm not writing the similarity statement because the instructions don't tell me I have to. So really make sure that you read the instructions. What about number 4? Yes. But there's no numbers. But what have we learned? First of all, aren't vertical angles the same? So that's one set of angles that are the same. And then alternate interior. You have 2 parallel lines cut by transversal. So this one is the same as this one. Or the other one works just the same. This angle is congruent to this angle. So even without having any of the actual angles, you can tell that these 2 are similar. Okay? Alright, that's shortcut number 1. Shortcut number 2 is called side, side, side. So if you have no angles but you have all of the sides, you can determine if they are similar. Here's what happens. You set up 3 proportions, okay? So you set up this over this, this over this, this over this. But how do I know which goes with which? Well, the 2 shortest go together, the 2 longest go together, and the 2 middle go together. And they all have to have the same scale factor. So on number 5, I would first just ignore this first triangle, or the second triangle, and look at this one. Well, 18 is the smallest, 27 is middle, 36 is long. So I'd go through and write small, medium, large, small, medium, large. So on this one, 14 small, 21 medium, 28 large. So now we know how to set up our proportion. So remember, I always read it like a book. So I always start with this triangle that's on the left side. So I would set 18, because it's the small, to the small over here, which is 14. 18 to 14, and then we'd have 27 to 21, and then we'd have 36 to 28. So then I would find the scale factor. I always go in first and just see if they all have the same exact thing. Even though it's a nasty decimal, I always just go plug them in and see if they're the same. If they are, then I'll go through the phase of finding the scale factor as a reduced fraction. Now, I have a fancy calculator where I can just press fraction and it gives it to me. You may not have that option. So what I would suggest is taking one of these 3, because they're the same, and just start reducing. Well, 27 and 21, I know 9 goes into both of those. So 9 goes into 27. Wait, 3 goes into both of those. I'm sorry. 3. So 3 goes into 27 how many times? 9. 27 divided by 3 is 9. 21 divided by 3 is 7. So the scale factor is 9/7. Okay, you try number 6. What'd you find? Are they similar? No. Because 27 divided by 36, 32 divided by 44, and 38 divided by 49, neither of these are the same. So I don't even have to worry about trying to reduce the fraction because none of them have the same scale factor. Yes? Yes?
Can you just, like, subtract 36 from 27? Because then it would be 11, 12, and then...
Yeah, but I guess the reason I wouldn't do that is because it doesn't help me get to the scale factor any quicker. When I plug it into my calculator, it's easy to get to the scale factor. Okay, all right, last shortcut. Shortcut number 3 is SAS similarity. So you have to know 2 sides and 1 angle, and that angle has to be in between the 2 sides you know. Okay, so the angle has to be in between the 2 sides, and the angle has to be the same. So 79 degrees, 79 degrees. Well, they have 1 angle that's the same. So now let's see if the sides are proportional. Okay, so you have to take the small side and the large, small and the large. So to set up your proportion, I would take 10 to 22 equals 25 to 55. Smallest of both of them, longest of both of them. So then I would see if they were similar. Well, I got that they both are the same decimal. So to find the scale factor, I would find that the scale factor is 5/11. Which that would be pretty easy to find from either of these. So yes. Okay, when it comes to number 8, you kind of have to use your imagination. So if you cover this half, that's triangle number 1. Okay? That's triangle number 1. If you cover the middle, that's triangle number 2. So you have 2 triangles. You have baby triangle that has 8 and 12. Then you have big triangle. Well, don't they both share this angle right here? So that's our angle that's the same. I don't need to know what this angle measure is because it's the same for both triangles. Okay, well if this triangle has 8 to 12, then this side would be 8 plus 6, which is, and then this side would be 21. Right. So I know the angle in the middle is the same. This is the small to long, small to long. So I'd have 8 to 12 is equal to 14 to 21. Those are both the same decimal, and they actually reduce to the scale factor of 2/3. So yes, they are similar. Okay. All right, what I would love to see you do is to finish 12 through 14. 12 through 14, we still have about 5-ish minutes. So finish 12 through 14 and also finish your math workshops, okay?